Hello! Thank you for watching, and welcome to the next video in my series on basic statistics. Now, as usual, a few things before we get started. Number one, if you're watching this video because you are struggling in a class right now, I want you to stay positive and keep your head up. If you're watching this, it means you've accomplished quite a bit already. You're very smart and talented, and you may have just hit a temporary rough patch. Now, I know with the right amount of hard work, practice, and patience, you can get through it. I have faith in you. Many other people around you have faith in you. So should you. Number two, please feel free to follow me here on YouTube, on Twitter, on Google+, or on LinkedIn. That way, when I upload a new video, you know about it. And it's always nice for me to connect with people who watch my videos online, wherever in the world you may happen to be. Now, on the topic of the video, if you like it, please give it a thumbs up. Share it with classmates or colleagues or put it on a playlist, because that does encourage me to keep making them for you. On the flip side, if you think there is something I can do better, please leave a constructive comment below the video, and I will try to take those ideas into account when I make new ones for you. And finally, just keep in mind that these videos are meant for individuals who are relatively new to stats. So I'm just going over basic concepts. And I will be doing so in a very slow, deliberate manner. Not only do I want you to know what's going on, but also why and how to apply it. So all that being said, let's go ahead and get started. So this video is the next in our series on hypothesis formulation and eventually hypothesis testing. And like the last videos, it's sometimes a concept that can give intro stat students headaches. It can drive them crazy. And the reason is that this concept runs counter to how we usually think about our everyday lives. And of course, this is the concept of type 1 and type 2 errors in hypothesis formulation and testing. Now remember, in previous videos we talked about what hypotheses are, we talked about how to set them up, pull data out of problems, and then set up our null hypothesis and our alternative hypothesis. Now remember, the null hypothesis is what we assume to be true. It's the status quo. It's the information we are given, or we assume to be the case. The alternative is where we go next if we have to reject the null hypothesis. So if we have to reject our assumption, then we proceed on to the alternative. Now, one thing we know by this point is that stats is never certain. It's never 100% perfect. So the way this usually works, as far as hypotheses go, we set up our hypothesis, we go out and collect a sample, we do some analysis on that sample, and then we reach some conclusion about our hypothesis. So the question is, does our conclusion from our analysis match the actual state of reality? So remember, we're basing that conclusion off some sample we took, and then we either reject or fail to reject our null hypothesis. But the question is, does our conclusion match the actual state of reality? Now we know it's not going to happen 100% of the time. And that, in a nutshell, is type 1 and type 2 error. Does our conclusion and our hypothesis test, due to our analysis, match the actual state of reality? Now, this is not just some academic distinction here. In real life, in real studies, in real research, the type 1 and type 2 errors can have literally life or death consequences. And I'm not over-exaggerating. So in the examples I'll use in this video, I'm going to show you that as starkly as I can. Now, the way I'm going to proceed is to show you a couple of non-statistical real-world examples that exhibit the idea of type 1 and type 2 error. And then we will proceed into more formal statistical ways of putting it. So, all that being said, let's go ahead and look at our first non-statistical real-world example. Now, I call this the fire alarm hypothesis. And unfortunately, it's something that a lot of us have to deal with at some point in our lives or in something similar, similar situation. And it goes something like this. Let's say you're going down the hallway at work or school, sort of doing your own thing. everything is normal as usual. But you encounter a sudden smell of smoke, like something's burning. Now, you know that may mean a serious fire is taking place in the building. Or it could be nothing serious. Maybe someone burned popcorn or something else in the microwave in the kitchen or cafeteria or wherever else you might be. But the question is, what do you do next? You have to make some decision on what you're going to do. So let's take a look at what might happen. If you think the smoky smell is nothing serious, you may decide that your assumption that everything is normal is correct, and therefore you will not pull the smoke alarm or the fire alarm. So maybe someone burned something in the kitchen. Of course, that's annoying, but it's not a serious fire. So you would just proceed on like everything was okay. And of course, you will not pull the fire alarm for that. Now, if you think the smoky smell is due to a serious fire, you may reject your assumption that everything is normal, and then you will pull the fire alarm. So you have to reach some conclusion based on the evidence around you about the state of reality. It's either a not serious fire or it's a very serious fire, and then you have to decide what you're going to do. So let's look at what might go wrong in this situation. So of course you smell the smoke and you think to yourself, this is not normal. So you reject the assumption that everything is okay. You reject your null hypothesis. Therefore, you go ahead and pull the fire alarm. So you rejected your null hypothesis that everything is normal, and then you went ahead and pulled the fire alarm. So the building is evacuated and the fire department arrives to investigate. Now, after the investigation, it is determined that there was no serious fire. You, quote, falsely pulled the fire alarm. Now, here's the way we interpret that. When you rejected your assumption that everything was okay, so you looked at the situation, you said, this is not normal, I'm going to reject my assumption that everything is normal, and then you proceeded. So when you rejected your assumption that everything was okay, when it really was okay, because there was no fire, you committed type 1 error, or in this case, a false alarm. So let's talk about type 1 error more formally. So type 1 error is rejection of the assumption or rejection of the null hypothesis when it should not have been rejected. So in the fire case, you rejected your assumption that everything was normal, but the reality was everything was okay. So type 1 error is rejecting the null hypothesis when it should not be rejected. You can think of it as incorrectly rejecting the null hypothesis. In this case, a false alarm. And again, this is a real-world situation, but is a perfect example of what type 1 error is. Rejecting the null when it should not have been rejected. Now let's look at what else might go wrong. Let's say you smell smoke, and you think, oh, it's probably someone who burned their lunch in the microwave. No big deal, so you go ahead and just proceed along your way. Therefore, you did not reject your assumption that everything is okay. You upheld your null hypothesis. You just sort of concluded it's not nothing serious, so you went ahead and just went on your way. But let's say there is indeed a serious fire. Now, no one is injured, luckily, but the entire building does burn to the ground. So when you failed to reject your assumption that everything is okay, when it really was not okay, you committed type 2 error. So let's formally define this and then we'll compare the two. So type 2 error. Failure to reject the assumption or failure to reject the null hypothesis when it should have been rejected. So incorrectly not rejecting the null hypothesis. So think about type 1. Type 1 is when we reject the null hypothesis incorrectly. Type 2 is when we fail to reject the null hypothesis incorrectly. So in the first case, we pulled the fire alarm when there was no fire. In the second case, we did not pull the fire alarm even though there was a fire. So again, we'll do some other examples, but this sort of sets the stage for basically what type 1 and type 2 error as it relates to our conclusion we reach and the actual state of reality. Now we can set this up as a little hypothesis. So our null hypothesis was the smoke is annoying but not serious. Everything is okay as usual. There's no serious fire. The alternative would be that smoke is evidence of a serious fire. Everything is not okay as usual. There is a serious fire. Now we can set up a little hypothesis table here. So on the left-hand side, we have the conclusion we reach. And then on the top, we have the actual condition or the actual state of reality. So let's go ahead and fill this in with some information. Now, in the conclusion side, we do not reject the null hypothesis. So no serious fire. Or we reject our null hypothesis that everything is okay and there is some serious fire. So those are the two conclusions we could reach in this situation. Now the actual condition of reality is there is no serious fire or there is a serious fire. Now we notice that there are two correct conclusions here. So if we do not reject the null hypothesis and there's no serious fire, and the state of reality is that there is no serious fire, that is a correct conclusion. Now if we reject the null hypothesis that everything is normal and there is a serious fire based on our evidence, and reality is that there is a serious fire, that is also a correct conclusion. So you can see our two correct conclusions there. Now the question is, where is the type 1 and type 2 error in this chart? Well, they go here. So let's look at the type 1 error situation first. So in the type 1 error, we reach a conclusion where we reject the null hypothesis. So in this case, we reject the assumption that everything is normal. And we think there is a serious fire going on. But the fire department arrives and they determine the actual condition is that there is no serious fire. So therefore our conclusion does not match the actual reality. Now let's look at type 2 error. So in type 2 error, our conclusion was that we did not reject our null hypothesis, and therefore we don't think there's a serious fire going on. But the reality is there is a serious fire going on. So we have a disconnect between our conclusion and the actual state of things. So you can see that we have two correct conclusions and two errors. Type 1 error and type 2 error. Now in general, the real-world consequences of a type 2 error are much greater. In this case, a type 2 error may mean the loss of property or even lives. So think about this. What happens if we commit a type 1 error in this case? Well, we think there's a really serious fire, so we pull the fire alarm. That gets everyone out of the building and it brings the fire department to the location. But it turns out there's no serious fire. Well, pulling the fire alarm is going to be a very big inconvenience to everyone in the building. But we pulled the fire alarm because we'd rather be safe than sorry, right? So the minor inconvenience of the fire drill is no match of the consequences of type 2 error. So look at type 2. We don't reject our null hypothesis. We think there's no serious fire going on, when in fact there is a serious fire. So we don't pull the fire alarm. What can the consequences be here? Well, if no one catches it in time, the building could continue to burn because there is a serious fire, and it could mean the loss of, course, property and lives. So while the type 1 error in this case is a real-world inconvenience, the type 2 error can cost property and lives. And that pattern tends to repeat itself throughout these examples. So let's look at another example, and I call this the andon hypothesis. Now you're probably thinking, what is that? Well, here's what it is. In a manufacturing system such as the Toyota production system, so Toyota, the car company, and other lean systems, line workers have the power and indeed the responsibility to stop the entire production line when they notice a serious problem. And this is done by pulling what's called an andon cord. So you can see in these pictures all along the production line there's a cord, like you might see on a bus or even a train. And if they notice something is seriously wrong, the worker is actually required in this environment to pull it. That will stop the entire production line dead in its tracks until that situation is resolved. Now the assumption is that the production line is running correctly. This is the minute-by-minute null hypothesis. So as things run, the assumption is everything is running smoothly, everything is running correctly. Now when a worker notices a defect, he or she has a choice to make. Should they pull the cord or not? If the andon cord is pulled, the worker is rejecting the assumption that the process is error-free. They are rejecting the null hypothesis. They are rejecting the assumption that everything is okay. If the cord is not pulled, then the worker is not rejecting the assumption that the process is error-free, thus maintaining the null hypothesis, and the production line continues to run. So it's all about rejecting or not rejecting the assumption that everything is okay. Now, what if the cord is pulled, which is a rejection of the null hypothesis, but nothing is actually wrong with the production process? Again, this is sort of a false alarm situation. In this case, the worker, quote, committed a type 1 error. They reject the null hypothesis incorrectly. They rejected the null hypothesis that everything was okay incorrectly. So type 1 error, again, is a wrongful rejection of the null hypothesis when it should not be rejected. Now, something about this. In the Toyota production system and in similar lean manufacturing systems, this is actually encouraged. This is perfectly okay. So if the worker thinks there is something wrong, they are required to reject their null hypothesis, reject the assumption that everything is going okay, pull the cord, and stop the production line. They are not supposed to worry about whether or not they are correct or incorrect. And that goes to the idea of the difference in the real-world consequences between type 1 and type 2 error, which we'll talk about here in a minute. But actually, this type 1 error is okay in this type of production system. Now, what if the cord is not pulled, thus supporting the null hypothesis, but something actually is wrong with the production process? So oftentimes sometimes a worker might be afraid to pull that cord because they don't want to be blamed for stopping production. And this is especially true in American manufacturing systems, where, at least previously to Toyota coming onto the scene, the idea was to produce as much as possible, as fast as possible. So what if the cord is not pulled, but something is wrong? In this case, the worker committed a type 2 error. So they failed to reject the null hypothesis. They failed to reject their assumption that everything is wrong when something was actually wrong. So type 2 error is wrongful support of the null hypothesis when it actually should be rejected. Now, note in this case, a type 2 error can be catastrophic. It may mean that hundreds or thousands of cars have that defect built into them. And see, this is why in the Toyota production system and other lean manufacturing systems, pulling that andon cord is encouraged, if not actually required, because the type 1 error, while an annoyance, is okay. If they stop the line for a couple of minutes, it's not that big a deal. It's going to mean a few cars off the end of the line that didn't produce. But think about the reverse. If a worker sees something that they don't think is right, but don't pull the cord and let that defect keep going and going and going, and then all these cars at the end of the line have that defect built in. That's why type 1 error in this case is really okay. But type 2 error is very, very bad. Very bad. And if it's a part on the car that's a safety issue, it can be very, very bad. So again, think of the difference between type 1 and type 2 error. In these two cases, type 1 was kind of a false alarm. So the alarm was pulled when there really wasn't a fire. The andon cord was pulled when there really wasn't a major problem. That's annoying, but it's not catastrophic in terms of the consequences. But type 2 is. In the fire case, if we don't pull the fire alarm and there is a fire, our building may burn down and people may lose their lives. In this case, if we don't pull the andon cord and there is a problem, that defect may get repeated hundreds or thousands of times. And that's the real-world consequence of type 2 error as related to type 1 error. Now we can set this up as a couple of hypotheses like we did the last time. So our null hypothesis is that the problem is annoying but not serious. Everything is okay. No major defect. So the normal running of the production line. Our null hypothesis is that the problem is serious. Everything is not okay as usual. There is a major defect. So we can set up our table just like this. So we have two conclusions we can make. We can accept our null hypothesis, or you can think of it as not rejecting. I should have changed that to not rejecting our null hypothesis, and that is no serious defect. We could reach the conclusion of rejecting our null hypothesis, that there is some serious defect going on. So that's the conclusion we can make on the line in the moment. Now the actual condition, maybe when the supervisor walks over, could be that there is no serious defect or there is some serious defect. Now if we do not reject our null and there is no serious defect, that's the correct conclusion. And actually that's the way the production line works, the vast majority of the time. We assume everything is going okay and there are no serious defects. That's a conclusion that is correct. That's a match. Now, if we reject the null hypothesis, we think there is a serious defect, and the reality is there is a serious defect, that's also correct. So our correct conclusion. Now let's look at the type 1 situation very quickly. So let's say we reject the null hypothesis, we reject our assumption that production is going okay without serious defect. We're going to reject that because we think there's a problem. Now the actual condition is that there is no serious problem or defect. So that disconnect between conclusion and reality is the type 1 error. So the production line might stop for a few minutes or even maybe less than a minute to check it. And then after we see there's no serious problem or defect, it just starts up again. Now the type 2 error, that's when we accept or fail to reject the null hypothesis. So we think everything is going smoothly, when in fact there is a serious defect going on, and that is type 2 error. And again, that gets replicated over and over and over into each successive car. So in general, the real-world consequences of a type 2 error are much greater. In this case, type 2 error would mean hundreds or thousands of defective cars, and maybe even unsafe cars as we proceed on down the line.